Hello everyone and welcome back to my YouTube channel. My name is Arnav Jain and I'm currently working as an SDE2 at Amazon. In this video, we'll be talking about the GoF Factory Method Pattern. So far, we have already completed the solid principles, and in our design pattern series, we have partially covered the factory design pattern. In the last video, we discussed the simple factory pattern. If you haven't watched that video yet, I highly recommend checking it out first. Without understanding the basics covered there, understanding the GoF factory method pattern might be a little difficult. I'll leave the playlist link in the description below so you can easily follow along with the entire series. Before we begin, if you find this content valuable and helpful in your learning journey, make sure to like the video and subscribe to the channel. I regularly share content around system design, design patterns, and software engineering concepts that are practical and industry focused. Also turn on the bell icon so you don't miss upcoming videos in this design pattern series. Now let's quickly recap what we discussed in the previous video. In the previous video, we discussed a logistics application. Initially, that application supported only road logistics. However, with the increase in demand and traffic, the system needed to support sea logistics as well. To make our application more scalable, we implemented the simple factory pattern. But while discussing the simple factory pattern, we also noticed that some design principles were still being violated. Specifically, first, the open-close principle, and second, the dependency inversion principle. We already discussed these problems in detail in the previous video. Because of these issues, we now want to improve our design. This is where the GoF factory method pattern comes into the picture. Now you might be wondering what GoF actually means. GoF stands for Gang of Four. The Gang of Four refers to the four authors who introduced many of the classic design patterns and helped formalize these concepts. These patterns allow us to build more scalable, flexible, and maintainable applications. Now let's take a look at the code for the simple factory pattern. Here, the main class acts as the client. From the main class, we tell the logistics app whether the delivery should happen via land or sea. Inside the logistics app, we use a factory method that decides which vehicle object should be created. So depending on the transportation type, if it is land, the factory returns a truck. If it is sea, the factory returns a ship. Now the factory gives us an object of type vehicle, and then we simply call vehicle.delivery. Here, vehicle is an interface, and both truck and ship implement this interface. So if the factory returns a truck, then truck delivery will be executed. And if the factory returns a ship, then ship delivery will be executed. This is what we call the simple factory pattern. However, this design has a few problems. We already discussed these problems in detail in the previous video. Since the factory class itself is causing these problems, we simply delete that class. But once we remove the factory class, we also need to update the logistics app because it was using that factory to create vehicle objects. So we remove the factory usage from the logistics app as well. Now the question becomes, how do we design the system so that vehicles can still be created without violating solid principles? This is exactly the problem that the GoF factory method pattern solves. First, we convert the logistics app class into an abstract class. Inside this class, we define an abstract method called createVehicle, which returns a vehicle object. Now you might wonder why we are using an abstract class instead of an interface. The reason is that abstract classes can contain predefined implementations. For example, in this case, we already have a delivery method with implementation. Inside the delivery method, we call createVehicle, store the result in a vehicle object, and then call vehicleDeliver. So the base class defines the overall delivery workflow, but it does not decide which vehicle should actually be created. That decision is handled by the subclasses. Now we create a subclass called Land Logistics. This class extends Logistics app. Since Land Logistics extends the abstract class, it automatically inherits the delivery method. The only thing it needs to implement is the createVehicle method. Since Land Logistics always uses trucks, this method simply returns a new truck object. Similarly, we create another subclass called Sea Logistics. This class also extends Logistics app, but its createVehicle method returns a ship object. So now each subclass is responsible for deciding which vehicle should be created. The base class only defines the workflow of the delivery process. Now if we look at the main class, which acts as the client, currently the client was creating an object of Logistics app. But if you notice, we have now converted Logistics app into an abstract class, and we cannot create an object of an abstract class directly. However, what we have also done is create two different subclasses. One is land logistics and the other is sea logistics. Both of these classes are nothing but subclasses of logistics app. So instead of creating an object of logistics app, the client will now create objects of these subclasses depending on the type of delivery required. For example, if client want to perform delivery via land, client will create an object of land logistics. Client want to perform delivery via sea, client will create an object of sea logistics. Now remember, land logistics is a subclass of logistics app. Because of this, we can assign an object of land logistics to a variable whose type is logistics app. Now if we call logistics app.delivery, since the actual object is land logistics, internally it will create a truck and the truck delivery method will be executed. If we change the object to sea logistics, then calling logistics app.delivery will internally create a ship and the ship delivery method will be executed. So the client code only interacts with the logistics app abstraction, while the actual object creation responsibility is handled by the subclasses. Now that we have converted the code from the simple factory pattern to the GoF factory method pattern, let's understand what we have actually achieved. This design provides multiple advantages. First, in the earlier implementation, the object creation logic was handled inside a separate class called vehicle factory. Inside that factory, we had conditional logic using if-else statements to decide which vehicle to create based on the transportation type. In our new implementation using the GoF factory method pattern, we removed the centralized factory class and the conditional logic. Second, the code now follows the open-close principle. If we want to support a new transportation method such as air logistics, we simply create a new subclass without modifying existing code. Another important improvement is that the code now follows the dependency inversion principle. At this point, you might wonder whether the dependency inversion principle is still being followed, because classes like land logistics directly create concrete objects such as truck. It may look like a violation at first, but it actually is not. Classes like land logistics and sea logistics are not high-level modules. They act as concrete factories whose responsibility is to create specific implementations. Since these classes are responsible for object creation, it is completely acceptable for them to instantiate concrete classes like truck or ship. This makes the system more scalable, easier to maintain, and easier to extend. And this is exactly the core idea behind the Gang of Four factory method pattern. Now, let's understand the UML diagram of the GoF factory method pattern. We start with the main class, which acts as the client. The client wants to use the logistics app. Instead of depending on concrete implementations, the client depends on the abstraction, which is the logistics app class. Logistics app is an abstract class that defines the overall structure of the logistics system. Now, this abstract class has two concrete subclasses. The first one is land logistics, and the second one is sea logistics. In the UML diagram, you will notice a solid line with a hollow triangle pointing toward logistics app. This means that land logistics extends logistics app and sea logistics also extends logistics app. Now let's look at the relationship with the main class. The main class depends on the logistics app abstraction, but at runtime, it creates concrete implementations, which are land logistics or sea logistics. Now let's go one level deeper into the logistics classes. Inside land logistics, we introduce an interface called vehicle. In the UML diagram, you will see a dotted line with an arrow from land logistics to vehicle. This represents a dependency relationship. Land logistics depends on the vehicle interface and it creates a truck object. Now, truck is a concrete implementation of the vehicle interface. Similarly, sea logistics also depends on the vehicle interface, but instead of creating a truck, it creates a ship. And ship is also an implementation of the vehicle interface. In the UML diagram, the relationship between truck and vehicle and between ship and vehicle is represented by a dotted line with a hollow triangle. It means a class is implementing an interface. So in this design, truck implements the vehicle interface and ship also implements the vehicle interface. This is the core idea behind the GoF factory method pattern. The client depends on abstractions, while the subclasses decide which concrete object should be created. Now we have understood both the GoF factory method and the simple factory method. Both factory approaches are widely used in the industry, and both are valid solutions depending on the problem you're trying to solve. If you expect that there will be many future changes in the object creation logic, then it is better to use the GoF factory method pattern. However, if you want to keep the design simpler and more straightforward, then the simple factory method is also a perfectly good choice. So with this, we have completed our GoF factory method. If you liked this video, and if this video helped you understand the concept better, please like and subscribe to the channel. Thank you for watching, and I will see you in the next video.